So you're looking to set up load balancing on pfSense with multiple WAN connections. I'm going to show you how to do that in this video. So whilst it does cover failover, if you're just interested in failover and nothing else, I have done a previous video on that. And failover without load balancing is fairly simple. So that's why they're in separate videos. And I hope by the end of this video, you'll understand why they are completely separate, because failover is pretty easy to set up. Load balancing, it's easy, but there's just a couple of things that you need to consider. So let's dive right in.
Sheridan Computers, IT, Communications, Support.
This is pretty much a base install of pfSense. Now, before we continue to configure load balancing, we need to make sure that our interfaces are working, both our WAN interfaces. So you can see here we have WAN 1, which is on 10.1.50.101. We've got our LAN, which is on 10.1.10.25, and we have our WAN 2, which is on 192.168.100.20. So we should be able to tell the difference between them. On the dashboard, I've added the interfaces and I've added the gateways. So our WAN 1 gateway is 10.1.50.1. and our WAN 2 gateway is 192.168.100.1. So adding this stuff onto the dashboard just makes it a lot easier to test any problems. And with the traffic graphs, we can make sure that the traffic's being load balanced properly. So I recommend that you at least add interfaces, gateways, and your traffic graphs to your dashboard. With that, we need to make sure that both our WAN 1 and our WAN 2 are working before we proceed to start configuring load balancing. So if we go to diagnostics and I head to ping, in the host name, I'm going to put Google's IP, Google's primary DNS server. We'll leave the protocol for IPv4. I'm just going to set the source address to WAN 1 to make sure that traffic is going out of WAN 1 properly. And if we hit ping, we should get a response from 10.1.50.101. So we have. So that's our WAN 1 IP address. And to test WAN 2, I'm literally just going to change the source address to WAN 2. Now we should get the same reply from 8888, but this time it should come from 192.168.100 subnet, which it has. So we've got the reply from 192.168.100.20 interface. So we've confirmed that both of our WAN interfaces are working. So with that, the next thing that we need to do is to configure our DNS. So I'm going to head up to System, and then we'll head to General Setup. Once we're in the General Setup, we have this DNS server settings here. So we need to set 2 DNS servers, one for each of our WAN interfaces. If you've got 3, then you're going to add 3 DNS servers. So we've got Google in here, as you can see, but I'm going to set the gateway to WAN 1, and I'm going to add a second DNS server. This time we're going to put 8.8.4.4 for Google's secondary DNS, and we're going to want that to use WAN 2. So let me save that. Okay, so changes have been applied. So this is the important section. 8888 WAN 1. 8844 DNS traffic is going to go through WAN 2. Now it's important that you set these up so your system knows how to route traffic. The next thing that we need to do is to set up our gateways. So what we're going to do again is head across up to System, and we're going to select Routing. So when you're in the routing configuration section, you can see we've got our gateways. This globe here that shows default gateway shows the current default gateway. So if whichever gateway it's using, this obviously shows the default one. You can ignore this line here. So we're using 1.2 DHCP and 1.1 DHCP. So with that, we need to create a gateway group. So we're going to go ahead to gateway groups, and then we want to add a new group, and we're going to call this load balancing. So the gateway priorities are obviously the priority in which gateways are used. So we want tier 1 for our 1.1 gateway, and we want tier 1 for our 1.2. So if you set that to tier 2, that basically sets it to failover, and we are going to do that in a minute as well. So if you've got a third one, you can set that to tier 3, and it'll try to use gateway 1, then it'll try to use gateway 2, and then it'll try to use the third one. We've only got 2, so we want to use load balancing, and we're going to set 1.1 DHCP, 1.2 DHCP, both to tier 1. And that's how we achieve load balancing. I'm going to set the trigger level to packet loss, which is used for failover. So we're just going to put load balancing, use both 1.1 and 1.2. We'll save that. Now, because we're doing load balancing, we also want some other gateway options. So we want an option to be able to prefer traffic to go out of 1.1, and we want an option to be able to prefer traffic to go out of 1.2. You'll see why this is important later. I will explain. So we're going to add another gateway. Gateway group, sorry. I'm going to put prefer 1.1. And then we're going to set our 1.1 to tier 1. But our 1.2 this time, we're going to set to tier 2. So if that'll try to send traffic out of 1.1, if 1.1's down for whatever reason, it'll go through 1.2. And again, we'll set it to packet loss or high latency and put a description in. So we're going to put prefer 1.1 fail to 1.2 and save that. Now we're going to add another one. These are optional if you're not going to use them, but they're handy to have anyway. It's not going to make any difference having them defined even if you don't use them. So I'm going to do add another gateway group. I'm going to put prefer 1.2. So what we're going to do this time is set gateway 2 tier 1. So that's a preferred route. And then we're going to set our 1.1 to tier 2. So it'll try to use this one first, and if that's down, it'll use 1.1. And then put a description in. So I'm going to put prefer 1.2 fail to 1.1. And apply those changes. It's handy to add these in, say, even if you don't use them. If in future you're going to add services that you might want to send some things out of 1.2, you might want to bind some things to 1.1, and it's just a good idea to have them in. So with that, we're pretty much ready to set up our rules for load balancing. So what we can do now, we'll go to gateways. I normally set these to a specific one, so prefer 1.1 fail to 1.2, which is for the pfSense routing itself. And if we do that and we save it and apply those changes, so what we're doing there is just telling pfSense itself that if it can't use traffic 1.1, use 1.2. Next thing we're going to do is go into firewall rules. And then on our LAN, so you don't want to be putting any form of gateways into your 1.1 or 1.2 for load balancing. Just kind of leave them. Firewall rules. So under LAN, you can see that we've got the default rules here. Excuse me. The default rule allowed to any rule. We need to set the gateway because it's going to use the default one, which is prefer 1.1 fail to 1.2, which is the default rule that we've just set under system and routing. Anyway, with that, edit the default LAN rule. Now if I change this to, sorry, where is it? Display advanced. Under gateway, I can see where it is. We're going to prefer this to load balanced. And we'll save that and apply the changes. We've got one more change that we need to make. And I should have done this first, to be honest. But if we go back into routing, the WAN 1 monitor IP by default is set to the IP of the gateway, and that's not what we want. So what these need to be is, when we went into general setup, DNS, we have these rules here. So we have Google's primary DNS is 8888. You can use whatever you want for these. Going out of WAN 1. And obviously 8844 goes out as WAN 2. So keep a note of them. What we're going to do is go to routing, and we're going to edit our WAN 1 gateway, and we're going to set the monitor IP down here to 8.8.8.8 for Google's primary DNS. Now, that's the one that's under our DNS. We've told it to go out of WAN 1, so you need to make sure that your DNS that you're sending through WAN 1, set that to the monitor IP in here. And it's important that you do that, otherwise you'll confuse pfSense with what's supposed to be where. And then we'll do WAN 2, and we'll set this to what we set our secondary DNS to, which is 8.8.4.4. And we'll save those and apply the changes. Okay, now what we've done there is, by monitoring 8888, if that's unreachable for whatever reason, then pfSense is going to assume WAN 1 is down. If 8844 is unreachable for whatever reason, it's going to assume WAN 2 is down, and that's how we can handle the failover. So you can probably understand now why the previous video I just covered failover, because it's easy. With load balancing, it gets a bit meh. So with that, we should now go to dashboard. We should now have our traffic load balanced. So if I go to fast.com, no, that's not going to go through there because I'm not using this pfSense as my router. What we can do is, if you can see we've got our IP addresses 192.168.100.20. Do it again. It's changed to 10.1.50.101. So you can see the load balance is working because our IP address is changing between ones. There's a couple of other options that we need to do just to get this working right. The load balancing will work from there, but there's a couple of things that you need to take into account when you're doing load balancing. If we go into System, and then I choose Advanced, under Miscellaneous, there's some options in here that we can check. Now, load balancing is obviously related to what we're doing. So use sticky connections. You're going to want to tick this box, more than likely. So successive connections will be redirected via gateways in a round-robin manner. So we're going to set use sticky connections, and what that will do is, if you've got two users, user 1 visits a web page and user 2 visits a web page, it will assign all traffic from that user to a particular gateway until the connections are closed. By default, this is set to 0. So if you visit a website, the browser once the remote browser closes a connection, then if you visit it again, chances are it's going to use a different IP address, as we did. Let me zoom this out. as we did here. So you can see that's changing, and some websites don't like this. It's usually set up for security reasons to stick to one IP address. So this is what the sticky connections do. So we can use sticky connections, and this source tracking, this is the important bit. Now imagine you're on a website, say you're booking a holiday and you're filling a form out. While you're filling the form out on that website, it might take you 10 or 15 minutes to actually complete that form. And what you have to remember is, if you when you hit submit, your IP address might change. So what we need to do is to set this to a reasonable value. So probably going to want to set it to at least 10 or 15 minutes, or how long you assume users are going to be filling forms out. You might want to set it to a lot higher. So it's in seconds. So you might want to set it to an hour, for example. You might just want to set it for 15 minutes. You might want to set it for 10. So obviously, if you're going to set it for an hour, 3,600, give the hour. So it's really important that you take this into consideration. Gateway monitoring is another option. So this option here, let me just save that changes, and then we'll go back up to that. Right, okay. So we've enabled this, which handles the filling out of forms. This gateway monitoring. So whether you want this to kill states for when gateways are down is up to you and depends on your network and your configuration. So we can do kill states when our gateways are down. Now, if you've got VoIP phones, for example, they might be set to register over a long period of time for UDP. So what we can do is, if we do kill states for which gateways are down, then that'll force traffic such as VoIP traffic to just end the connection and re-establish the connection. If you don't do that, your phones might not actually realize the gateway's down and try to keep the connections over that particular gateway that we're going through. I'm not trying to confuse you here, so hopefully I'm explaining this well. Now, if you're not using VoIP phones and you set this, it could be more problematic than not problematic, because if you're using failover, for example, and gateway, and your secondary gateway goes down, yet your primary one is active, then it will force your states to flush, and it can just cause you problems that way. So unless you actually need it, I'd leave it on default. So do not kill states on gateway failure. So skip route. If you want to send, say, user 1 through WAN 1, but not have access to WAN 2 if WAN 1 fails, then that's what you can do with do not create rules. So you can set one rule to send it through WAN 1 and then one rule to block it. So that's what that's for. Do not add static routes for gateway monitor IP addresses. Generally, you want this unticked, so that's how we set our primary DNS to go through WAN 1 and our secondary DNS to go through WAN 2. I just wanted to make you aware of them, because there are situations, especially if you're using VoIP, where you might want to kill all states for which gateways are down. I'm just going to leave that as a default. We've already applied it. I'll do it again, no harm. So with that, browsing websites now won't cause you any problems, unless if you set the source tracking, where was it? If you set this to 1 hour and it takes somebody 2 hours to fill a form out, it could cause issues. So generally set this to a sensible value. That sensible value depends completely on you and your users' behavior. If they're not filling forms out, you can leave it. But generally, it's a good idea to actually put something in here. So with that, go to status, dashboard, and now if we keep doing that, that's what the tracking source states does. I'll just make sure that all traffic destined for that address from the specific user that I'm using, the IP address of the user. So all traffic from this system now will go through all traffic from the system that I'm using to that website or any other website will go through the connection that has been assigned. So after an hour, it'll time out. But if user 2 has got a different IP address, might send them through it might send them through the different gateway and do the load balancing. So with that, there's one other thing to keep in mind, and that is how you do the load balancing. So you've got your primary connection that's a gig, and your secondary connection's only 100 meg, 50 meg, whatever it is. Then you might want to change the weight of the gateways so that more traffic goes through 1.1 than 1.2, or more traffic goes through 1.2 than 1.1. So let me just show you how to do that real quick. If we go into system and we go back into routing, so system, routing, and we've got our gateways here. Now, if we go and edit any of the gateways, and we go down to display advanced, we have the weight. So by default, the weight is 1 unless you change it. If I change this to 2 for 1.1, then twice as much traffic will go through 1.1 as 1.2. If I change it to 4, then 4 times more traffic will go through here than will go through 1.2. If we had this set to 1 and 1.2 set to 2, so the weight of 1.2 gateway set to 2, then twice as much traffic would go through 1.2 and goes through 1.1. The data payload, you probably don't need to worry about. This just gives you the option to change that, where sometimes it doesn't work. I'm not going to get into that. Just leave it as default and it should be fine. Now, latency thresholds. If you remember when we set the gateway groups up, we set it to fail on, let me just go back into this. I'm going to go into gateways, gateway groups, I'll edit this. So trigger level was packet loss or high latency. And if we go back into routing, gateways, and I go back into here, go back to display advanced, this is where these thresholds come into. So you've got latency threshold and packet loss. Depending on your internet connection, you might need to change these to have it working properly. The defaults do usually work fine, but I just wanted to make you aware this is where you configure the thresholds for failover. So for load balancing, it's not taken into account, but for failover, it definitely is. And these are the thresholds you set. So when one connection becomes unavailable, it'll switch to the other one, and it's how long it takes before it comes back as well. I don't think there's much more in here that we need to set. So how often ICM probes will be sent. So that's checking the gateways live, which is 500. And then we've got loss interval, time periods, and alerting interval. So there's not really much that you need to change there. This option at the bottom, use non-local gateway. Some ISPs have wrong network setups and the gateway is out of your subnet. If it is, you can use that to specify it. But I just wanted you to be aware of those settings as well. The other thing to consider when you're setting this up is NAT. So you want to make sure that your outbound NAT is set right to use both of your interfaces. So if you set to automatic, then you won't have anything to worry about. You'll see it's automatically put these rules in. But if you've got it set to manual, just be aware you need to put the NAT rules in for 1.2 as well. You can copy them from 1.1. Now, when I did a fast.com, the traffic didn't go through my firewall because my system is not, the gateway is not set for this test firewall that we've set up. But we can test it with, if I do iperf minus P2 for dual connections, let's see example.com. It's iperf 3 on FreeBSD. Now if I go to status and dashboard, you might think that it's not working. Most of my traffic is appearing to go through 1.1. That is actually what we want, and it's doing that because of the because of this option that we set. So if I go into advanced miscellaneous, this use sticky connections. So that just makes sure that all my traffic goes through the same connection. So it's not it's all my traffic from my IP address will go through that same connection, which is why it looks like the load balancing isn't working, but it actually is. It's just that we've got it set to 3600. If I untick this, let me zoom out of this. If I untick this and then I save that, and then we go back into status and dashboard. If I do this again, both of my 1.1 and 1.2 should work because it'll be sending one connection through 1.1, the other through 1.2, or however it was with the weight of the gateways that we set. And just to show this, you can see that now both 1.1 and 1.2 are sending connections out to the internet. And again, if we just head over to System, Advanced, and then we scroll down and find, where was it, load balancing? It was up here somewhere, wasn't it? So miscellaneous, and then re-tick this use sticky connections, and it's set to 1 hour. And you can set it to 10 minutes, 15, whatever you want. And then we save that. You'll see when I do this again, it'll either use 1.1 or 1.2. Even though I'm using 2 connections, they should all go through the same connection. Now you can see everything's going through 1.1. Yeah, that's random. It could have gone through 1.2. It just picked 1.1 and it's sending all my traffic through there. So hopefully you now understand what the source tracking is under that miscellaneous option for this one here. Under this use sticky connections. So if I'm visiting a website, I'm there for 10 minutes, it's going to basically send all my connections for any website through that for an hour, and then it might switch over. But it is working. It's not going to send everybody. It just changes on IP address. Leave that on. So you generally want that set. Oh, and then status, dashboard. So when we do this, again, you can see everything's going through 1.2 this time. So it has changed, and it'll load balance that way. But now all my traffic's going through 1.2. I'll do that again. And you can see it will do until I change that setting. Again, just to cover the firewall rules, if you wanted to change, if you wanted to change it to failover instead of load balancing, we can go through the advanced options, and wherever the gateway is, we can set it to prefer WAN 1 or whatever we want. So you can set multiple rules up for multiple devices and decide how you want to do the traffic. I think we're done. I can't think of anything else off the top of my head that you need to know. But I just wanted to demonstrate how to do that. A lot of tutorials and things that I've seen generally don't cover the sticky states, or don't cover them enough to make you understand what they do. With that, so I hope you can see why I didn't cover load balancing and failover in the same video, and they did actually need 2 separate videos to do it. Because if you're just setting up failover, there's not much to consider. It's easy to do. If you're doing load balancing, there's a couple of things that you just need to take under consideration before you actually do it, and hopefully I've explained most of these in this video. If I have missed anything, please leave it in the comments. If you found this video useful, give us a like, allow other people to find the video. Consider subscribing to the channel, hit the notifications icon, and you might get notified of any videos that I do. Thanks for watching, and I'll see you in the next video.